that matrix 7 minus 2 0 4 1 0 0 0 5 with the 3 by 3 matrix. We are going to find the eigenvalues, the characteristics equation, the corresponding eigenvectors. We are going to multiply A by this vector 1, 2, 0, and we'll check if it is an eigenvector of one of the eigenvalues. And if it holds, we state the eigenvalue that it is. After which, we have to get a basis for the eigenspace of the other eigenvalue that is not this one. Then we verify Cayley Hamilton Theorem. So the Hamilton Theorem says that CA is equal to 0. That's the characteristics of A. Substituting A is equal to 0. And then finally, we show that A is invertible and we use the Hamilton Theorem. Number 1, the eigenvalues. So the eigenvalues, we have A minus lambda and
the determinant of that
equal to 0. This will give us the characteristics equation and it will give us the eigenvalue. Okay? So we have A minus lambda I. I will just do minus lambda, minus lambda, minus lambda. So we have 7 minus lambda minus 2, 0, 4, 1 minus lambda, 0, 0, 0, 5 minus lambda. If I get the determinant of this, it will be 0. So the determinant of this is easiest computed among this. Right? So this is plus, minus, plus. So we have 5 minus lambda. I'm going to close this column, this last column, and close this last row rather, and close this last column. And then I have times 7 minus lambda minus 2, 4, 1 minus lambda. Right? This is equal to 0. This is 5 minus lambda, 7 minus lambda, times 1 minus lambda, minus 8, plus 8 is equal to 0. So I just evaluate this one inside. I have 7, minus 7 lambda, minus lambda, minus 8 lambda, plus lambda squared, plus 8. So this is 5 minus this time, this is equal to 0. So I have 5 minus lambda, lambda squared, minus 8 lambda, plus 15 is equal to 0. This one is the same as what? Plus 5 minus 3. So we have lambda minus 5, lambda minus 3. Right? Minus 3. Because minus 3 times minus 5 is plus 15. Minus 5 plus minus 3 is minus 3. So this is equal to 0. So what do we have? We have lambda is equal to 5 twice. We have to do the multiplicity. And then lambda is equal to 3. So the next, first of all, our characteristic polynomial is to multiply this all out. So from here, this is our eigenvalue. From here, I can multiply it out. I have characteristic equation, perfect lambda. I have 5 lambda squared minus 40 lambda plus 75, yes, 75 minus lambda cube plus 8 lambda squared minus 15 lambda equals to 0. So what would it give me? So the characteristic equation related to lambda is minus lambda cube
plus 13 lambda squared
plus 13 lambda squared times this
minus 55
minus 55 lambda
plus 75.
that was this and this, then plus 75 plus 75 equals to 0. So that's the characteristic equation. The next characteristic polynomial. Okay. If it's characteristic polynomial, you know write is equal to 0. But if it is characteristic equation, you write is equal to 0.
Okay.
Now, corresponding eigenvectors. For lambda is equal to 3. We have what? A minus 3i times some vector x is equal to 0. Okay? So So, but a minus 3I is substituting 3 here, 3 here, and 3 here. We have 7 minus 3, we have 4, minus 2, 4, 1 minus 3, minus 2, 0, 0, 0, 5 minus 3, 2, times some x, y, z is equal to 0, 0, 0. So we can row reduce, right? We have that, I can say this minus this. I have 1 over 4, row 1, will give me 1, minus 1 over 2, 0. Nothing happens here.
What?
Divide 0 by 4, we have 0. Next one, we have this minus this, row 2 minus row 1. We have 0, 0, 0 is equal to 0. Then for this last one, we have 1 over 2, row 3. We have 0, 0, 1, 0. Okay? So we have that x minus half y is equal to 0. And we have that z is equal to 0. So here this implies that what x is equal to half y.
Z equals to 1.
No, this is 1 times z is equal to 0.
Okay.
So we can let y be some beta, because it's in let's say beta. So we have that x is equal to half beta, right? Therefore, the vector of this x is equal to x, y, z is equal to half beta, beta, 0. I can bring out beta. I have beta, half, 1, 0. Okay. So that's the first eigenvector. Next, we check for lambda is equal to 5. We'll do the same thing. We have a minus 5i times some x is equal to 0. But a minus 5i is 7 minus 5 is equal to 2 minus 2, 0. 4. 1 minus 5 minus 4, 0. 0, 0, 0. Is it not? Then we have x, y. Why did we make what?
Why?
Why did we make y? B, yes, it's a constant.
Why?
It's free. It can be anything.
Okay.
X is equal to half y. So y can be anything. Just let one of them be fine. This is equal to 0. This implies we are going to row reduce again. I divide by half. I multiply by half rather. I have half row 1 is going to give me 1 minus 1, 0. X, y, z. Then you fix your 0. The next one, I'm going to say this minus 2 of this. You see that this one is 2 times this row, right? So I'll say row 2 minus 2 row 1. What would that give me? 0, 0, 0, 0, 0, 0. And then the last row is 0, 0, 0. So we have 2 free variables. Here we have 1 free variable because we have 1 0 row. Here we have 2 free variables because of we have 0 row. So we have let z equal to, okay, first of all, which rows are free? The free variables are, we know that z must be free. So let z be gamma. Then y also must be free. So let y be beta. Then we have x minus y is equal to 0, right? So this means that x is equal to y, right? And if x is equal to y is equal to beta, then our eigenvector will be, so this is the same thing as writing beta into bracket 1, 1, 0 plus gamma into bracket 0, 0, 1. If you multiply and add, it's going to give it the same thing. So, if you are going to say the space line, you say it's the set of this vector such that beta and gamma are elements with R. Okay, the next question is what? I'm going to multiply A by this vector 1, 2, 0, and we'll check if it is an eigenvector of one of the eigenvalues. And if it holds, we state the eigenvalue that it is. Multiply A with 1, 2, 0. So I have 7 minus 2, 0, 4. I'm copying from here. 1, 0, 0, 0, 5. Yes?
What the eigenvalues you have 5? No,
Sorry, this is 3. Sorry. Sorry. So this times 1, 2, 0. What will this give me? It will give me this times this 7 times 1 7 plus minus 2 times 2 plus minus 4. That will give you 3. Then I have this times this. What will it give me? 4 plus 2, 6. Right? Then this times this is 0. So what eigenvector does it correspond to this? Where B is 6. Right? We have half, 1, 0. So this is the eigenvector of the eigenvalue 3. Lambda equals 3. So number 4. Now outside number 3, we are on number IV now to get a basis for the eigenspace of the other eigenvalue that is not this one. They say we should find the basis. If they say find the basis, is just you remove this one, remove the plus, just this comma this. So the basis is the set 1, 1, 0. This is where we are for lambda is equals to 5, comma 0, 0, 1. This is the basis.
Write it to basis.
Basis of what?
Of lambda is equals to 5. We verify Cayley Hamilton Theorem. So the Hamilton Theorem says that CA is equals to 0. That's the characteristics of A. Substituting A is equal to 0. Cayley Hamilton Theorem says that, oh, who took the characteristic equation? So the Cayley Hamilton equation is minus lambda saying that CAA is equal to 0. This is what we need to verify. Okay? But we got that the characteristic equation is what? Minus lambda cube plus 13 lambda
minus 55 lambda
plus 13 lambda minus 55 lambda
plus
75.
That's the
So we need to change lambda to the matrix A. We have A squared is equal to 7 minus 2, 0, 4, 1, 0, 0, 0, 5 times 7 minus 2, 0, 4, 1, 0, 0, 0, 5. So what will this give me? This will give me this times this. We have 0 at this answer. 7 times 7, 49 minus 8, 41. This times this, we have 7 times minus 2, minus 14.
Yes,
7 times minus 2,
minus 14.
minus 14. 2 times 1, minus 2 times 1, minus 2. 0 times 0 is 0, minus 16. The next one,
0,
this
0,
times
0, 0,
0.
everything is 0.
This times this,
16.
28. This times this, 28. Plus this times this, plus 4, 32. 32. Then this times this, we have minus 8 plus 1 minus 7. Put your mind there, don't make mistake. This times this, 0. Then this times this, 0. This times this, 0.
0.
This times
25.
25. So that's A squared. Now A cubed.
Unfortunately, I cannot square matrix again.
A cube is
A times A squared.
A squared times A.
anyone, they will give you the same thing. 41 minus 16, 0. 32 minus 7, 0. 0, 0, 25. Times
7 minus 2, 0. 4, 1, 0. 0, 0, 5.
Thank you.
Nice.
So what will this give us? We have this times this. 41 times 7. 287.
Wow.
Is that what? Okay, we don't need calculator in math department.
Okay, thank you very much.
Okay, this times this. Plus.
164.
Huh?
You know what minus 64 is?
No, minus 64 plus 7.
Just what?
So we have 3, 2, 2. So we have 2, 2, 3, right?
No, 3. Okay, minus.
Okay. 16 times 4 minus 16 times 4. Also, this times this.
Yeah.
This times this. We have minus 82. This times this. Minus 16. So we have is 98. Minus 98. 0. Then the next one, this times this. 32 times 7. 4 carry 1. 21, 22.
2 to 4.
Minus 28. 200 minus 4. 196. Okay, then we have this times this. We have minus 64 minus 7. Right? Minus 71. 0.
0.
Then
1 to 5. 0.
0. 1 to 5. If we make any mistake, it's going to affect. So C A is equal to minus times this 2, 2, 3 minus 98 0 196 minus 71 0 0 0 1 2 5. Plus 13 times this 41 minus 16 0 32 minus 7 0 0 0 25. Suleiman, why?
You don't sense me.
This is for 55 7 minus 2 0 4 1 0 0 0 5 plus 75 times the identity matrix. This is times 1, so times the identity matrix. 1 0 0 0 1 0 0 0 1. So let's add. We have this is minus 2 2 3 98 0 minus 196 71 0 0 0 minus 1 2 5. Plus multiply this. Plus 1 times 10 plus 5 plus 533 minus
208.
Okay.
minus 208. Any small mistake will start again. No, start again. 0.
416. Because I'm sure I'll take it another one.
Minus 208 0 4
416.
416 minus
91.
91 0. I'm trusting you before. 0 0.
Yeah, trusting you to just right.
What's the answer?
1625. Wait, no, that's wrong.
325. 13 times 25.
325, sorry. I wonder what it is.
Wow.
325 minus. Okay, I want to do the plus because I don't want them minus. Plus this times this.
Minus
5 times 7. 385.
Minus 385 plus
110.
110 minus times minus plus
Okay, yeah.
0
Minus 220.
minus 220 minus 55 0 0 0 minus
275. I'm sure it is.
275.
okay plus 75 0 0 0, 75, 0, 0, 0, 75. Now let's add.
Hold on, no, that's 75 is on.
This plus this plus this plus this. So yeah. We have 5, 3, 3 minus 2, 2, 3. What's that? 3, 1, 0. Minus 3, 8, 5. Minus 75 plus 75, 0. The next one is this plus this plus this plus this, right? So you have 98 plus 110, which is 208. Minus 208, 0. 0. This place should be 0. Then this plus this should be 0. Because this and this will give you this. So 0. Then 71 plus 75. 71 plus 75.
No, 71 minus 91 first now.
Okay, that's minus 20.
Minus 55.
Minus 55. Minus 75. Okay, 0.
Hi.
The next one, 0, 0, 0. Therefore, Cayley Hamilton's theorem holds. We show that A is invertible and we use the Cayley Hamilton's theorem. How do we show A is invertible? We need to show that the determinant of A is not 0, right? If you consider the determinant using this rule, we have plus, minus, plus, right?
Yeah.
So we use 5. We have determinant of A is equal to 5 times this whole place. We have 7 minus 2 for 1, right? Determinant of this. And this will give me 5. 7 times 1, 7 minus 2 times 4 plus 8, 15, 75, right?
Okay.
Which is not 0. Therefore, A inverse is. That's A is invertible, right? Now we want to find A inverse. We are going to use Cayley Hamilton's theorem. We have seen that this whole thing is equal to 0.
Yes.
We have seen that C.
Okay.
Yes, exactly. We have seen that CAA is equal to 0. It implies minus A cubed. Plus, I'm substituting A here. So plus 13A squared minus 55A plus 75I is equal to 0. Now we know that A inverse exists, so I can multiply from my A inverse. So I have A inverse times minus A cubed plus 13A squared minus 55A plus 75I is equal to A inverse times 0. I told you if I multiply from the left, you must always do the same thing from the left. So what do you have? We have minus A times this. A inverse times this goes with 1. So we have A squared plus 13A minus 55I because A inverse times 8I minus 75A inverse is equal to 0. Plus. Thank you.
It's minus.
It's plus now. So, once we make A inverse the subject of formula. So we have A inverse is equal to 1 over 75 A squared minus 13A plus 55I. So what did I do? I took all these other ones to the other side. So the sign changed and then I divided by 75 to 75 of A inverse. So for those that have strength, you can take it as your own assignment. Substitute inside here and get your A inverse. Okay? So you already have what your A squared is. You have what A is and you know what I is. You substitute and you get your answer.
So but if you stop here, you start now.
Yes. But why do you stop there?
No, I'm just saying.
Alright, are we ending here?
Yes.
No, we have a new
Yes, bro.
question, but I want to. Thank you for watching. Please subscribe to my channel. I like the video. Like the video.
Thank you for
Like
watching.
this. See this one. And please comment. And please comment on the video.